Hello there and welcome to exercise 6a, which we're going to be doing a bit of revision of some of the geometry concepts that we have covered before in years 8 and even back into year 7 possibly. And you need to remember that when we're talking about geometry, what we're actually talking about is we're talking about just looking at shapes and their angles basically for this particular topic. Now, some revision. When you've got a right angles add up to 90 degrees. So for these two angles, you've got x plus 30, they'll add up to 90 because you've got a 90-degree angle when it's a right angle. Notice that I write the reason in brackets. We're going to start to really focus on this a bit later on. So it's probably a good idea to get into the habit. Whenever you do geometry questions, you write down an equation of some kind. For example, the two angles, x and 30 add up to 90, and then in brackets after that first line of working you always give a reason, and if we minus 30 to both sides we get x equals 60 degrees. Let's have a look at another situation. We know that angles when they're on a straight line add up to 180, so in this particular question you've got two angles, a 2x plus 5, you've got an 82, so those two angles will add up to 180. So here we have our 2x plus 5, and there's our 82, adds up to 180. Why? Because they lie on a straight angle, straight line. Straight angles add up to 180 degrees. You always give your reason. Now I'm going to add the 5 and the 82, which gives 87, minus the 87 to both sides. That'll give me 2x equals 180, take 87 is 93. So 2x equals 93. Now I'm going to divide both sides by 2, and 93 divided by 2 is 46.5 degrees. So that's the process that you go through if you've got angles on a straight line. What about if you've got a whole lot of lines meeting at one point? And here's our point just here. They all meet at that point there. So the angles about a point always add up to 360 degrees because there's a full revolution around that point. So we've got the 110, the 70, the 41 and the 3x all add up to 360 degrees. And we write the reason in brackets because the angles about a point always add up to 360 degrees. So let's add the 41 and the 70 and the 110. And when we do that, they add up to 221. So we get 3x plus 221 equals 360. Now we're going to minus 221 to both sides, and 360 take away 221 gives 139. So we get left with 3x equals 139. Now we're going to divide both sides by 3. 139 divided by 3 is 46.3 recurring, or 46 1/3 degrees. There's a fourth situation, which is probably the easiest of the angles at a point, and that's when you've got two lines that cross over, vertically opposite angles are equal. So in this case, x and 110 are equal, and these two angles here would be vertically opposite. They're equal to each other as well. So we write our answer down, x equals 110 for this question, and the reason, because they're vertically opposite. Now you'll need to also remember when we deal with parallel lines, we have three different situations that occur when you have parallel lines. The first one that we get are the alternate angles. And that's where we're trying to spot Z shapes. So if I look at some parallel lines, I can see a Z shape, which means that I can see those two shaded yellow angles are equal to each other. But the Z could also be drawn backwards, which means that my shaded angles could be in a slightly different position. And we need to remember that those alternate angles are equal. And the other thing we can do, which a lot of people don't realize often, is if those angles are equal, those alternate angles, that means the lines are parallel. And if the lines are parallel, that means the angles are equal. So it works both ways. Another type of angle you can come across are the corresponding angles when you've got parallel lines. And sometimes we refer to those as F shapes. So you can see an F shape, and underneath each of the arms, if you like, of the F, we have our two corresponding angles. Now the F could be written backwards. That's okay. Or it could be written upside down. That's okay. It's always underneath the F shape, or it's upside down and backwards. So there's 4 different ways our F shape could be situated, but every time you generate those corresponding angles, the angles are equal. Our last type, they're the trickiest type for parallel lines, and that's where we deal with cointerior angles, sometimes called C-shape. So you can see our C-shape, and it creates 2 angles. They are not equal. Those 2 angles, A and B, add up to 180 degrees. The C-shape could also work backwards, or a backwards C, and still creates 2 angles that add up to 180 degrees. Now let's just review our angle names that we've learnt in previous years. If an angle is between 0 and 90, it is called an acute angle. A 90-degree angle is called a right angle. If it's between 90 and 180, it is called an obtuse angle. If the angle is a 180-degree angle, it's called a straight angle. If it's between 180 and 360, it's called a reflex angle. And if it's exactly 360, we call it a full revolution. Sometimes it used to be called a perigon, which is the old-fashioned term for a full revolution, but you don't need to know that one. Now, triangles. Let's review some triangles. Now, every triangle has 3 sides and 3 angles. And every triangle has 2 different names. It has a side name and an angle name. So let's look at the first one, a scalene triangle. This is a side name. A scalene triangle is a triangle that would be drawn where all 3 sides are different in length and none of the angles are the same length. The second one is called an isosceles angle. An isosceles triangle, not angle, isosceles triangle has 2 sides that are the same length and the third side is a different length. And where those 2 sides come in contact with the third side, you have 2 angles that are equal. So that's an example of an isosceles triangle. We have an equilateral triangle. In an equilateral triangle, all angles are the same and all sides are the same. So I've got 3 side lengths marked on there, and all angles are always 60 in an equilateral because the 3 angles have to add up to 180 in a triangle, and 60 plus 60 plus 60 adds up to 180 degrees. The triangle names using the angles, well, you've got an acute angled triangle where all angles are smaller than 90, a right angled triangle where one of the angles is exactly 90, and an obtuse angle where one of the angles is bigger than 90. Now, there's also a commonly forgotten rule about the exterior angle of a triangle. Now, when you're dealing with a triangle, this angle here is called the exterior angle because when we look at our triangle, if I extend this line out, it creates the exterior angle. And the exterior angle always equals the 2 opposite interior angles added together. So the outside angle equals the 2 inside angles that are opposite it added together. Here's a overview of what quadrilaterals are. Now, a quadrilateral is a 4-sided shape. Now, if we look at 4-sided shapes, you can start to specialize and you can start to look at your 4-sided shape and you can actually follow this path and say, well, your 4-sided shape could be classified as a kite. Now, this is probably a bit easier to read in your booklet handout, but the kite basically has, as it says there, 2 pairs of adjacent sides. Adjacent means beside each other. So 2 sides next to each other are equal length. One diagonal of a kite bisects the other. That means they the diagonals cut each other in half. So if I actually was to draw my diagonals in, it's a bit hard here, but if that's pretty poor. Let me try something different here. If I actually did this, if that's a kite, there's the diagonals, and those diagonals cut each other in half, so that means that this length and this length are the same, and this length and this length are the same. So there's a bit of information about kites. If it's not a kite, it could be a trapezium. Come down here to trapeziums. All a trapezium needs is one pair of parallel sides. If you take it further and you had two pairs of parallel sides, you could be ending up with a parallelogram, and if the parallel sides have right angles and they're equal, opposite sides are equal, you end up with a rectangle. If they're not right angles, you end up with a rhombus if the sides are equal, and you end up with a square as your basic shape. But this is just a bit of information about different special quadrilaterals, and most of them you've come across before anyhow. Now, a polygon. This is something you would not have seen much of before. A polygon is a figure that's just got straight sides, and we don't know how many sides it's got. So a polygon could have 4 sides, 3 sides, 12 sides, 100 sides, as long as the sides are straight. A regular polygon means all sides are the same length and all inside angles are the same size. Now there's 2 formulas that we need to remember for polygons, and here's our first one. All of the inside angles of a polygon with n sides add up to the number of sides take away 2 times 180. So an example, let's say we had a 10-sided shape. Well, you'd have 10 take away 2 times 180, which is 8 times 180, and when you times 8 and 180 together, that tells you what all of the angles will add up to in an 8, oops, I drew 8, I meant 10-sided shape. Anyway, hopefully you get the idea. If I drew a 10-sided shape, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's my 10-sided shape. All those angles inside that will add up to 8 lots of 180 degrees. We'll do some examples in a moment to clarify that anyhow. Now, the other rule that we need to be aware of is that all of the outside angles of any polygon add up to 360 degrees. Let's draw a polygon. There's a polygon with 4 sides. I'm going to extend each of the sides. So what we're saying is that this angle, this angle, this angle, and this angle all add up to 360 degrees. That works for any shape. Let me try a triangle. Extend the sides out. That angle, that angle. Whoops, those sides weren't extended out very carefully. Let's go back and do that properly. That's better, so they're all going in a clockwise motion. That angle, and that angle are all angles that add up to 360 degrees. And again, we'll do some more work on that a bit later on. All right, let's go straight to our examples now. Here's our first example. Find the value of the pronumeral, which in this case is the letter E. That's an external angle. There's our triangle. There's the outside angle. Remember the rule, the external angle equals the 2 opposite inside angles added together. So E is equal to 50 plus 50 because the external angle of a triangle is equal to the sum of the opposite angles, so E is 100. So I've given the reasons. Question says, give reasons. There are my reasons for why that statement to start off with is true. Let's go to part B. I've got a 4-sided shape. I know all 4-sided shapes have 4 angles that add up to 360, so I'm going to add the 4 angles and make them equal 360. Here are my reasons. Because the angle sum of a 4-sided shape, a quadrilateral, is always 360. Now I can add my angles that I know together. 120 plus 77 plus 83 adds up to 280. So I get 5x plus 280 is equal to 360. Now I'm going to take away 280 to both sides. 360 take 280 is 80. Then I'll divide both sides by 5, and I end up with x equals 16 degrees. So there's our first example covered for part B. Let's go to part C. Now I can see a right angle symbol here, so I've got three angles that add up to 90 degrees, so I add them together and I put equals 90. Here's my reason. Right angles equal 90 degrees. Now 24 and 21 add up to 45, so I get x plus 45 equals 90. Subtract 45 to both sides and x is going to equal 45 degrees. Let's progress on to example 1, part D. We've got some parallel lines. Now, there are a lot of different ways you can do this, but I'm going to look at that 73-degree angle. I'm going to mark in another angle that's 73 degrees, and I'm writing it with an arrow vertically opposite. That's showing why that's 73 degrees. That's my reason. That's 73 degrees because these two angles here are vertically opposite. Now, if I was to focus on that 73-degree angle written in red and the 2y, they are inside a C shape there for the parallel lines, which makes them cointerior. And I know cointerior angles always add to give 180 degrees. So the two angles, 2y and 73, add up to 180. There's my reasoning. Let's minus 73 to both sides. 180 take 73 is 107. 2y is equal to 107. Now I'll divide both sides by 2. 107 divided by 2 gives me 53.5 or 53.5 degrees. So there's example 1 finished. Let's progress to example 2. Now it says, find the sum of the interior angles of a regular polygon that has 24 sides, and then it continues on to say how large is each angle. Well, we know that all of the angles inside a polygon add up to the number of sides take away 2 times 180 degrees. In this question there are 24 sides, so I need 24 take 2 times 180, which is 22 times 180, which gives me 3,960 degrees. I put that into the calculator, that's what I generated. So for my 24-sided shape, there's going to be 24 angles inside it, and all 24 angles will add up to 3,960 degrees. Question then says, how large is each angle? Well, because it's a regular polygon, regular polygons mean all sides are the same length and all angles are the same size. So I know there's 24 angles, and I know that all of the angles add up to 3,960, so each angle is 3,960 divided by 24 because there's 24 angles. And put that into your calculator and you'll get 165 degrees for each angle in the shape. Let's try example 3, our final example for this exercise. We've got parallel lines, but I don't see any F shapes, C shapes or Z shapes because my parallel lines don't have a transversal. That line doesn't go all of the way through, or this line doesn't go all of the way through. So what I'm going to do is introduce another parallel line. I'm going to put it there. So it's parallel to the other two. I've got 3 parallel lines. So now if I look at my question, what I've actually got, and I've probably drawn it in a little bit quick, let's just go back. That's the one I want there. I have alternate angles. So if this angle at the top's 49, that shaded bit there is 49. Then I can look and see I've also got alternate angles for the bottom part of my diagram. So if this is a 12-degree angle here, that's a 12-degree angle there. So x is equal to 49 plus 12, which equals 61 degrees. But what I haven't done with this question yet is given my reasons. And that is something I forgot to type in. So I'm going to put here why I get 49 degrees, because it's alternate. Why do I get 12 degrees? Because I've got alternate angles. Could even go like that. It's not an L, that's a symbol that looks like this. It's our angle symbol. Got alternate angles, and that would then Mean x we can see as the two angles added together, so that's now okay. Let's get you now to go on and try answering questions from exercise 6A. Have fun.